Okay, this is 2017 HL2 math. Let's see, time zone, same one we were just working on. So paper 1, time zone 2. Uh-oh. Is this the one I was looking at before? Oh, that's funny. Guess I thought this was a calculator problem. That's hilarious. Well, lucky I did it non-calculator, 1 through 4. That's so funny. I'm such a dork. Except I didn't do number 4 non-calculator. Huh. So I'll have to adjust number 4. Well, let me just do number 4 now. So we had done part of number 4 on the other one. So the S was t plus cosine 2t. T is greater than or equal to 0. We found the velocity. And we set it equal to 0. And then I decided to start using my calculator. Okay. So negative 2 sine 2 equals negative 1. And then sine 2t equals 1/2. Okay, cool. Well, at least you know how to do it the non-calculator way too. When is sine 1/2? This totally is possible with the calculator. Sine is 1/2. Remember, all students take calculus or a smart trig class. This is sine is 1/2, so 1/2 is here. That's radical 3, so that's 30. 30 and 180 minus 30, supplement, which is 150, because this reference angle is 30. I took a derivative, so I did calculus, so I need to be in radians. So this one is 5 times, right, times 5, so that's 5 pi over 6. Okay. So now, technically, let me show you the official way, in case this was a regular trig problem. So it's 2t equals, so let me write this over here. So in math analysis, I kind of go like this so you could see it better. So 2t is pi over 6 plus 2 pi k, and box is 5 pi over 6 plus 2 pi k. Now, if this is in another question on solving equations, this is number 4 again, if I would need to divide by 2, so if I wanted all answers, I guess we'll multiply by 1/2. If I wanted all answers, I do have to multiply the restriction also by that 1/2. So t is pi over 12 plus pi k, and t is 5 pi over 12 plus pi k. So it turns out that k equals 0, I think, gives me the first 2 answers. But if you remember this from math analysis, you had to plug in multiple k's potentially to get all the values that you needed to get. So this one is t equals pi over 12 if you plug in a 0, substitute in a 0. If you substitute in a 1, you get 13 pi over 12. I was finding a common denominator right here. And then this one, same thing. So if k is 0, and then this has its own ... And then this t, if k equals 0, you get this, but then you get, what, 17 pi over 12 if k is 1, and then you get more answers. And so it wanted the smallest answers. So this is the smallest answer, and then 5 pi over 12 is smaller than the 13. So that's interesting. So if you didn't do the 2 pi k, you would still be correct. That's so funny. I did it the whole calculator way. I see this time zone 2, and I got myself all messed up. How funny. Anyway, I'm just thinking, what back on the other one did I use? Oh, okay, so this is T1. So T1 is pi over 12, and T2 is 5 pi over 12. And then it also wanted me in part B. So this is 4B, this is 4A. So in 4B, they also wanted me to find, let's see, I forgot. So displacement of the particle when t equals 1. So they wanted S of pi over 12. And that's pi over 12 plus cosine of 2 pi over 12. And that's pi over 12 plus the cosine of pi over 6. Pi over 6 is 30 degrees, so cosine of 30 degrees, so we have a picture up here already. Cosine is radical 3 over 2, so that's pi over 12 plus radical 3 over 2. I'm so curious, though. Type that into the calculator and see if it matches. That's so funny. Anyway, so usually I do what if it wasn't calculator. This time it's what if it's, I did what if it was calculator, right? In the other video. Anyway, let me quickly scan. I did not use a calculator in number 3. And number 2, I drew it. So the only part is that you would really have to plot points, kind of see what it is. I kind of drew a little sketch, but I saw the cube. So I saw the cube and I knew what a cube looked like. And then it was stretched 2 and then moved up 5. So if you look back at number, and then number 1 I actually did without a calculator. That's so funny. Okay. Anyway, so don't put a calculator in the way on the non-calculator section. Anyway, what a dork I am. Okay, so let's see. So number 5, it's only 4 marks, but it's weird. It's like a square. Okay, a square and an Argand diagram. Okay, an Argand diagram just means that it's a real and imaginary. So it's when you graphed like, say, 2 plus 3i in math analysis, you went over 2, you went up 3, you didn't put the I, you just put a dot, and that was how you graph it. So that's an Argand diagram. So Argand diagram. That's what an Argand diagram means. Okay, now that's not this question specifically. Okay, so let's graph this question specifically. So this question specifically says, let me just write this neater here. Let me erase this. So let's see. So that's just a little reminder, but I could have reminded you with the actual problem. So A is related to the complex number -1 plus 4i. So as a coordinate, A would be -1, 4. Okay. And then B, -3 plus 0i, oops, no parenthesis there, would be -3, 0 as a coordinate. Okay. The shape is a square. You can use the graph paper. So if you want to, there's graph paper. You just ask the person who's proctoring your exam. That's it. So if you want graph paper, ask for a piece of graph paper. I'm thinking I'd be happier with graph paper on this one. So I can just ask myself for a piece of graph paper and I just go like this and there's grid lines. Okay, so feel free to ask for a piece of graph paper. Usually they say they need to make it available. So unfortunately, it's make it available, and IB doesn't have them give it to you automatically. So that's kind of stressful. Anyway, on graphs, you are allowed to use pencil for IB. I don't know how that works now because, sending across the country or scanning. So we'll just have to make sure that's still the rule. Okay, so this one is point A. -3, 0 is right here. That's point B. -3, 0. Okay, now I get their picture. And they want to know the complex numbers by C and D. Okay, so I'm thinking squares are perpendicular. So I feel I want to use the perpendicular thing. So I'm thinking, what is the slope of AB? So IB, they call it the gradient, okay, but the slope. So I feel like the slope is rise 4, run 2. Hey, I used my graph and I could see it better, or you could just find the slope. You can also write that as a vector. So I probably could write BA as a vector, even though I'm doing complex numbers, so that's a little strange. So in the x direction, I would go +2, and then in the y direction, I would go +4. Interesting way to link topics. I'm not sure I would directly use vectors for this one. Okay, so I'm thinking that the perpendicular slope, I should flip the rise and the run, so that would be -2/4. Now I'm not reducing because I'm thinking the lengths would be nice if the lengths were kept the same. So this is my new rise over run. So from A, and I'll change colors here. So from A, I'm going to go down to right 4. Oh yeah, that's perfect. And that is point D. Okay, and then it looks like this slope of a square should be the same. So this should be down 4, left 2. And that'd be point C, and then this. Oh, I'm so glad I asked for a piece of graph paper, a supposed piece of graph paper. Okay, now it says it's 4 marks. So I think the coordinates would be the marks. Now, so the coordinates is asking for the coordinates. No, it says the complex numbers, but let's CD. So this is over to the right 3 up 2. And this C is right 1 down 2. So this would be 1 minus 2i. Not the vector, but the imaginary number. And 3 plus 2i. Interesting. It'd be interesting to check the mark scheme to see if I got all the points with doing it this way. Because I can imagine equations if I wasn't on graph paper. But I feel like I kept the lengths the same. Pythagorean theorem, right? Pythagorean theorem, these lengths are the same. 2 and 4 on each side. Definitely the sides are the same. I made them perpendicular, so they'd be a square. It's worth 4 marks. There's 4 numbers. I feel like I'm good. Interesting. Very strange question. Remember that the word gradient is in IB, the word for slope in the USA. Okay, so slope, NIB, gradient. Okay, so number 6. Let's see. What's number 6 say? Number 6, substitution. X equals tan theta. Okay, x equals tan theta, that's a trig sub. Now, trig sub is possible in IB. Not so much in AP, although you can always use it if you want. They took it off the AP test a few years ago. Like, I don't know, 20 years ago. Tons of years ago. But anyway, so they took it off, but we still teach it because we want you to know it for college. Okay? Because it's still in the college level textbooks, which is the one that we use. It's in the college level textbook. So just because it's not on the AP exam doesn't mean we don't want to teach it to you. Okay, why did the bounds change? Okay, the bounds change because they changed from x's to thetas. So I do need to change the bounds. So if I'm noticing right now, I might as well change them. So right now this is an x, so these are x bounds. So if those are x bounds, then I could substitute it in. I'm just thinking, do I want to do the bounds now? What do I want to do? Okay, so here, I'll write the bounds over here. Okay, so the bounds, x equals 1 means that 1 equals tangent theta, and theta equals tangent inverse of 1, which has multiple answers, but pi over 4 is definitely one of them, so we'll go with pi over 4 because that's the answer they have. Okay, let's separate out our x equals 2 bound, so 0 equals tangent theta. And then when is tangent theta? 0, and that's what they wanted for the bottom bound. Okay, so I feel like I'm convincing enough on the bounds. Okay, so trig substitution, we practiced these. You just also had to identify them. The fact that it's a plus is why we're using tangent. Remember, secant was if you had this, and sine substitution was if you had this. Okay, but you don't have to really know that except for college. Okay, so you don't need to know that for the class. Okay, but still, we have experience doing trig sub. So you take the derivative, so dx equals secant squared theta d theta. I just took the derivative. And then I'm going to substitute and hope for the best. So let's see. So I'm going to write theta equals 0. Theta equals pi over 4 because we already did it over there. 1 over x squared. So that would be tangent theta squared plus 1. And then that's squared dx. So dx is secant squared theta d theta. Let me highlight those so you could see it. You probably remember. dx, that's what dx is over here. Secant squared theta, I can substitute that in. Okay, now we have the right letter. So theta, I can drop the theta equals is. So that's 1, tangent squared plus 1. Okay, so remember sine squared plus cosine squared equals 1. If you want tangent, you can divide by cosine squared. So sine over cosine, cosine over cosine, 1 over cosine. Now, for IB, this is probably in the formulae. But for AP, we have no formulae. Okay, so that would be, okay, so that's the same thing, right? Isn't that the same thing as tangent theta squared? Just looks funny. Okay, so this would be secant theta squared. Squared. Now that looks funny to me. Let me put this on this one. So secant squared theta squared. There's still this squared, right? That squared is this squared. This inside is this. Okay. I don't have to be too careful because they did give me the answer, so I'm probably okay. D theta. Okay, so this is a secant squared theta over secant to the fourth theta. And 0 to pi over 4 d theta. Okay, so that cancels. Now that exponent right there, that 2, kind of looked like it was falling and becoming a 2 theta. So this would be 1 over secant squared theta. I don't know where they're going to assign the points, so I never know. So I just decide, hey, if I know the step, I'm just going to show the step. Cosine theta d theta, integral 0 to pi over 4, which is what they gave me. So check. Now, it is possible that if you did not know how to do number 6a, you could still use 6a to do b. Okay, so if they give you something in a and you don't prove it, you can still use it for b. Okay, so this is 0 to 1, 1 over x squared plus 1 squared dx. So this is from, I would call it from part A. So from part A, that's 0 to pi over 4 cosine squared theta d theta. Now in the formulae, they don't actually have the cosine 2 theta formula, but this is the formula you're going to look for, cosine 2 theta. Okay, cosine 2 theta has two formulas. There's 2 cosine squared theta minus 1, or cosine 2 theta equals 2 sine squared theta minus 1. Oops, not that one. It's 1 minus 2 sine squared theta. Those are in the formulae, so see if you can find them. Okay, so in AP, we memorized the integral, but in IB, sometimes you need it the other way, and sometimes they assign marks the other way. So it's safer. So this is 1 plus cosine 2 theta divided by 2 equals cosine squared theta. And this is sine squared theta. Negative 1 plus cosine 2 theta divided by negative 2. So we could change those signs. Multiply everything by negative 1. So those are the formulas that I remember. But in AB, we don't expect you to do that. So you'll have to check. We'll put right here, check mark scheme. Okay, because I'm afraid that if you went directly to the calculus formula, the integral, it's not going to give you all the points. Now, sometimes it does, sometimes it doesn't. It depends who's assigning the points. Okay, so it is something that you might need to know for the future anyway. We had some of those in polar problems. So this is 1/2 theta plus, if this is u, then you get another 1/2, so that's sine 2 theta over 4, which is the formula that you recognize, 0 to pi over 4. So my question would be, look at the mark scheme and see if they gave you a point for this one. Now, it's 1 point. Who cares about 1 point? But, you know, if you know it, and it is possible that you'll need to know it for another circumstance. Okay, so 1/2 pi over 4 plus sine of 2 times pi over 4 minus 1/2 times 0 plus sine of 0 over 4. I usually show both substitutions just to be safe. And the other day, I substituted in the bottom one first and then subtracted the top one, so I don't know what the heck I was doing. Fortunately, I had students there, and so they told me. So here, who knows what errors I make. 0 minus sine of 0. Is it 0 or is it 1? So substituting 0 in doesn't always give you 0. Pi over 8 plus sine of 90. So sine of 90, sine starts here. This is my sine squiggle graph, right? So at 90, it's up to 1. Or you can use the unit circle if you like the unit circle way. So sine of 90 is 1, so that's 1 over 4. Because remember, I'm on the non-calculator section. Okay, I'll wait for time. 20 minutes. Okay, so we're pretty good. Let's see. 7, 6, 7. Let's look at what 7 is, especially since I redid 4. The random variable x has a Poisson. Okay, Poisson, 7. It's not 9, so I'm not too worried. We'll see. Poisson m. Okay. So given that x is greater than 0 equals 3/4. Okay, so my calculator's not going to work. There's no inverse Poisson. So Poisson is like binomial. So individual x values, okay, but they keep going forever in Poisson. And in binomial, there's an n that stops. Okay, so for this one, this is 1 minus Okay, so this is 1, 2, 3, 4, dot, dot, dot. So I would take the whole probability, which is 1, and I would subtract the missing number, which is 0. Kind of reminds me of water balloons. Okay, so 0 equals 3/4. So that would be negative probability. Now, is it greater than or is it equal to? No, it's equal to. Okay, so equals negative 1/4 divided by negative 1. Probability x equals 0 is 1/4. Now, look in the formulae. There's the formula. So it's e to the negative m. So I don't know the m. So e to the negative m. And then it's m to the x, or the a, and that's this value right here, over that blue value again, factorial. And that has to equal 1/4. Okay, so e to the negative m times 1 over 1. Remember, 0 factorial is 1. Oh, that's interesting. We can actually solve this one. Cool. Cross multiply. How do you get rid of the m? I know you did this on your own already. So ln, right? ln both sides. M comes in the front. M ln e equals ln 4. ln of e is 1. M equals the ln of 4. Okay, cool. Did it say find m? Find the value of m in the form? ln a. A. Cool. So should I change it to 2 ln 2? Because that's ln of 2 squared. No, because they told me ln of a. They didn't tell me b ln a or something like that. So they just told me ln of a. So this is not the answer that they want. So that's the answer. Cool. So that was A. Okay, so that's A, 7A. The random variable y, okay, B. I wouldn't usually write B over here, but it'd be nice if we could see it all together. The random variable y has a different Poisson distribution. Its mean is 2m. How cool that it's not in a word problem. Okay, find the probability that y is greater than 1. Now that m is the same m as in part A. So this is the Poisson of 2 ln of 4. Cool. Okay, I'm thinking we're going to bring that 2 up to be ln of 4 squared, but we don't need to think that right now. Okay, so I only did that because I substituted the m right here. Okay, that's y. So this is the y distribution. Okay, find probability of y greater than 1. Greater than 1 and greater than 0 is different. So what is that? That's probability of y equal to, greater than 1 would be 2, 3, 4, 5, etc. So this is going to be 1 minus the probability that y equals 0 minus the probability that y equals 1. You could either subtract them individually off or put a big parenthesis and then a plus. Not on the calculator section. Okay, so this is 1 minus e to the negative mean, 2 ln 4. And then it's mean, 2 ln 4 to the x over x factorial. Okay, that's kind of creepy. Okay, minus e to the negative 2 ln 4. Okay, that doesn't have to do with the 1. Times 2 ln 4 to the 1 over 1 factorial. It's so weird. Like, I don't remember this test. So I don't know why I wouldn't remember this test. 4 squared, I'm sure I've given exams on this before. Anyway, it's very odd. Or I just forget all the exams because I like to solve them each year. There's no fun in redoing them. Okay, knowing what to do with them already. Isn't that weird that 0 factorial and 1 factorial are both 1? Okay, so 1 minus, I did bring it up because I wanted those to cancel. So that's now 16 times 1 over 1 minus, oh, why did I put a negative? Oh, the formula has a negative. Lucky I wrote it once correctly. So that negative 2 is right here. So let me write that in red so you notice where I made an error. So this negative 2, when it comes up, becomes a negative 2. Oh, okay, so I should bring that one up too and make that a positive. Okay, so the red is just so you can see my corrections. 1 minus, I was thinking, how am I going to get a fraction? Because it looked like there's a fraction. Okay, cancel. 4 to the negative 2 minus 4 to the negative 2 times 2 ln 4. how fun. So now we have to make it look like that other thing, but it's way up there, so I got to figure out what it is. 2 ln 4. Okay, so they want me to do, let me write it over here, b minus ln c over c. Oh, that's cool. Look, the bottom is the same as the inside. So is that true? The denominator looks like it's 16. Okay. Minus 16 ln of 4 squared. That's the ln of 16 over 16, negative. These we could work out. This is 16. Gosh, math is so awesome. 15 over 16. Okay, cool. 15 minus the ln of 16 over 16. Huh. It's like you're matching multiple choice answers, but in a more creative IB way. So very fun. I love these questions. Okay, so that's 25 minutes. Let's see how I feel about 8. Math induction. Oh yeah, let's wait on 8. Okay, 9. Oh, 9's long answers. So I guess this 25-minute video is all we're going to do right now. Do I want to show all the steps of the math induction? That's kind of cool. I don't know. It's a ... I think it needs its own video just for number 8. Ooh, n is greater than or equal to 3 on 8. How interesting is this one? So we'll have to ponder it. It's like a ... with a binomial. So I don't know if you know this. So if you completely gave up on 8, let me just give you a hint so you could try it before watching my other video, is 2 plus 3 Remember, that's our 2c2 plus 3c2. So in my opinion, I would write it like this. And then this is n minus 1 c2 equals nc3. So I would use this notation. It's perfectly allowed, but it's going to totally mess us up if we're trying to use IB notation in the middle of a math induction problem. So it does say n is an integer. And then it says n is greater than or equal to 3. So in the basis step, you won't start where you usually start. You'll start with 4 n equals 3. You're not going to start at 1 when it says it starts at 3. So that's really cool. And then you would do your basis step, and then you do your induction step, and I don't know, we'll see. It'll seem interesting. I think it's going to take me too long to put on this video. I don't know, but then the short answers are done. Okay, let's see. And we'll just make another 35-minute video. For n equals 3. So for n equals 3, that's 2c2 plus, okay, so if 3 was here, that's 2c2. So that's it. So for n equals 3, it's only that term. Equals this substituted in there, which is 3c3. Okay, well, is that true? I think it's true. They're both in the front of, right? They're both in the front of the, of Pascal's triangle, right? So this is 2c2, and this is 3c3, but I'm thinking I don't really want to explain it that way. So I think I should just subtract and do the formula. So 3 factorial. Remember, we're not on the calculator section. 0 factorial, 3 factorial. Okay, so 1 equals 1. Maybe I would just put the statement is true. Okay, so let's see. Let's see how long math induction actually takes. Okay, so induction step. Induction step. You should pause and don't just copy mine. Try it yourself before you do this. Okay, so induction step. We need to show the conditional statement. If blank, then blank. Okay, what's my if blank? If blank, my if blank is if the statement, I'm going to abbreviate statement ST, don't do that on the AB test. If the statement is true for n equals k, then the statement is true for n equals k plus 1. Okay, so you're going to assume the if part. So you have your assume section, then you have your we need to prove section. So assume the statement, don't abbreviate on the AB test, is true for n equals k. Okay, that is assume what? What is the statement for n equals k? The statement for n equals k is 2c2 plus 3c2 plus 4c2 plus dot 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 plus k minus 1c2 equals kc3. We need to prove we need to prove the then part. So we need to prove this yellow part. So we need to prove the statement is true for n equals k plus 1. Okay, that is, we need to prove, don't abbreviate on the AB test. That is, we need to prove that 2c2 plus 3c2 plus 4c2 plus dot 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 plus k plus 1 minus 1. Interesting. C2 is k plus 1 C3. Okay, so let's start on the left side. So the left side. Now when you do the left side, make sure you don't change the left side. So 2c2, 3c2, 4c2 plus dot 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 plus k plus 1 minus 1 C2. And this is going to be the goal later. Okay, so somebody's missing right here in the dot dot dot. So TC2, so I expose the person who's sitting in the dot 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 right to the right of this one. I could see why their notation is better because it's kind of hard to do these subscripts. Okay, so this would be, what would be here? So instead of a k plus 1 in the front minus 1, it would be the term before 401, which is 400. So this would just be a k c, well, a k minus 1 because this minus 1 is still here. So k, let me write that again. So that would be k minus 1, just a plain k minus 1, c2. And then what always happens is this part right here, not always, but often in the dot dot dot, like often meaning always, I can't think of an example when it doesn't, is going to match this one. So this right side can be replaced with this whole thing with the dot dot dot. That's so cool. I've never done it with highlighter. Okay, so this is kc3 plus k plus 1 minus 1 c2. Okay, how awesome is that? That's supposed to be k plus 1 c3? Okay, kc3 plus k c2. I have no idea. So I'm thinking, let's change it back to the other form. I don't know. Throw my math at it. K factorial over k minus 3 factorial times 3 factorial. Is that right? 8c3 would be what? 8 factorial, 5 factorial, 3 factorial? Did I do that right? K factorial, yes. K minus 3, yes. 3, yes. Okay, so I'm fine. Okay, so they don't really need to see that. Okay, so that's k factorial over k minus 2, 3 factorial. Factorial. How awesome. It's like a common denominator. I'm trying to get to this. So I'm thinking I need a k plus 1. But I need, let's kind of look, k plus 1 minus 3 and a 3 factorial and a k plus 1 factorial at the top. Well, this is k minus 2. I see the k factorials. I like the 3 factorials. I like the k minus 2 factorial. Now, what's k minus 2 factorial? K minus 2 factorial is k minus 2, and then you go down, right? So 8, 7, 6. So I go down. So down is k minus 3 factorial. So if I put, let me change colors so you can see better. I'm going to put it in, let me put this over here. So I'm thinking if I multiply this by k minus 2, top and bottom, that makes my denominator k minus 2 factorial. Maybe we should have done another we need to show step. like we do with divisibility. Because this is cool, but this is like a crazy one. I would have been in long answers. We would have been doing the long answers. This is k factorial minus 2 times k factorial. I would have been doing the long answers because remember, after an hour, move to the long answers. Okay, we did this with the divisibility where we kind of put boxes. So now that my denominator is the same, -2 green boxes plus 1 green box is -1 green box. So -1 green box, the green box is k factorial. Kk plus kk factorial. Kk factorial is like an encouraging thing. I was going to call that k plus 1 factorial. What did I do wrong? 35 minutes. I wonder, do I need to pause? K minus 3. Did I do something wrong? What am I trying to match it to? K minus 3 would be k minus 2, 3 factorial. We kind of got a k minus 2. Okay. K minus 2, kk plus 1. Because I see the k plus 1 factorial, if I could just toss that. Oh, I found my error. Oh, that's so awesome. Let me highlight it for you. See this right here? Not supposed to be a 3. Okay, so how did I catch it? You know, I tell you about I wish it were. So let me show you what I wish it were. See this 1 right here? I was thinking this part right here is k plus 1 factorial. That's k plus 1 factorial. I really would like to cancel those. But they don't cancel because that's a 1. So I really wish this number 1 right here in red was not a 1. Well, how could it not be a 1? Well, if it was a 2, it would cancel. How could it be a 2? And then I realized, oh, when I was writing out my factorial right here, I made a typo. Anyway, so let's fix that. This is not a 3. Okay, so I'm going to delete it. So that is not a 3. That is a 2. I'm going to write it in red so you can see it. So that's a 2, which means if I want to make that a 3 factorial, I'm going to have to multiply that by 3. Okay, but now that's a 3. I don't want that to be a 3 either. I wanted it to be a 2. Interesting. I do want it to be a 2. I want that to be a k minus 1. I really don't see where I went wrong. See, this is why I need you guys. 3k factorial. So now it's a 3. I didn't want it to be a 3. I wanted it to be a 2. Well, that's a plus. Oh, okay. No, I was making another mistake. K times k factorial is not k plus 1 factorial. Okay, we're moving along. This is true. It is a 3. So that is a k minus 2 factorial times 3 factorial. Okay, so I see the k factorials at the numerator. I'm going to factor out a k and get k plus 1 over k minus 2 factorial, 3 factorial. Now, k plus 1 factorial, like 9 factorial, or 9 times 8 factorial. Okay, 9 times 8 factorial is 9 factorial. So this is k plus 1 factorial over k minus 2, 3 factorial. Which is k plus 1 over k plus 1 minus 3 factorial, equals k plus 1 c 3. Is that what I wanted it to be? Oh my gosh. Okay, blah, 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 blah. So fill it in with all those extra math induction words, you know. blah, blah, blah. Thus, therefore, da, 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 da. Okay. Wow, that was crazy. But that's 40-minute video, so we're really long here. Anyway, you get to see math induction. Careless mistakes. What are you going to do? Okay, here we go.